Applications of direct variations. I'm going to start reviewing some problem-solving strategies. And the first thing we want to remember is we should always read the problem first completely. Then read and highlight the key information. And then read it for a third time, underlining what we're solving for and the units we're looking, or the units we're using. Then we need to choose a tool or a skill that we've had this semester to solve the problem and create a model. Then we're going to apply all of the knowledge we've accrued to solve the problem. Then we're going to think about whether or not our problem has a reasonable solution. The graph you see on the screen represents the activity in a person's bank account. Okay. You can see we've got a title. Our independent variable is the week number. Our dependent variable is the bank balance. We can see our scale. We look at our scale on our dependent axes. We've got 1, 2, 3, 4, 5 boxes to get to a number to week 5, which means each box represents 1 week. And if we look at our dependent variable, 1, 2, 3, 4, 5 boxes to get to $500. So $500 shared equally amongst 5 boxes tells me that my scale on my dependent axis is 100. Does the graph indicate that the person is depositing or withdrawing money? Justify. Let's read that again. Does the graph indicate the person is depositing or withdrawing the money? You need to justify. So are they depositing or withdrawing? If I look as the weeks increase, my bank balance also increases. So that would indicate that the person is depositing money. Does the graph represent a positive or a negative correlation? Positive or negative correlation? Does the graph represent a positive or a negative correlation? That's what I'm looking for. We're going to go back to the graph. The line rises to the right, so that must be a positive correlation. And you can see we've got some answers written here. Initial value, state the initial value and the rate of change. So what am I looking for? State the initial value and the rate of change. State the initial value, that's what I'm looking for, and the rate of change. If I look, the initial value is what we start with. That's right here on the graph. So I'm starting with nothing. Now my rate of change, I need to use some points on the graph, and I'm going to pick some nice points. So I'm going to pick this point here and go up here. And I said each horizontal box represented 1, so I increased by 2 when I went to the right, and I went up 1, 2, 3, 4 boxes. Let me try that again. 1, 2, 3, 4 boxes it looks like, so that's a positive 4 increase. So my rate of change is rise, which is positive 4, over run, which is positive 2, and I increase. Oh, I made a mistake. What did I forget? I went up 4 boxes, but each box is actually 100, so my increase was 400. So my rate of change is positive 200. Don't forget to watch the number of boxes in your scale. Okay. The initial balance in the bank, we set the 0. This is all the same thing. The rate of change would be represented as $200 per week. Notice we have units in a rate of change. When we're thinking about applications of slope and direct variations, we need to think about units for slope because it's representing a comparison between 2 variables. The behavior of the function. What is the function doing? As the weeks increase by 1, the slope tells me that the total amount in the bank account increases by $200. And we know the initial value is 0, and we know the slope is 200. So we know that we can come up with an equation in the form y equals mx to represent the bank balance, except for we wanted a variable for the bank balance that made sense. So we can use B, and M we said was 200, and the number of deposits or weeks would be N. Use the equation to determine the bank balance in the account after 12 weeks. Use the equation, that's important, the equation B equals 200N, to determine the bank balance after 12 weeks. So what am I actually looking for? I'm looking for the bank balance. And I can write myself a capital B there to remind myself that's what I'm looking for. After 12 weeks, that tells me N is 12. So now I can just substitute into my equation 200 multiplied by 12, and I need my handy dandy calculator, and that's 2,400. So I know that the balance in my bank account after 12 weeks is $2,400. Use the equation B equals 200N to determine how long it will take to have a bank balance of $5,225. We're going to get our handy dandy highlighter again. Use the equation B equals 200N to determine how long it will take to have a bank balance of $5,225. And let's just make sure we know what we're solving for. Use the equation B equals 200N to determine how long, that's N, it will take to have a bank balance of 5,225. Well, that's my B value. So I start by writing my equation out again, and I substitute in what I know. 5,225 equals 200N. In order to get N by itself, if I think back to my solving equations unit, I have to divide both sides by 200. And I see that N is 26.125, and I can't have part of a week. Well, I don't really understand what 0.125 weeks is. So somewhere between 26 and 27 weeks, I will have that balance. However, I'm only depositing weekly, so I have to wait until I make my 27th deposit after 27 weeks in order to get to that balance.